Hello and welcome to today's webinar on integration of Endress+Hauser Ethernet IP-enabled devices to the Rockwell Automation Plant PAX process control system. My name is Mike Wright, and I am the Process Automation Team Sales Manager for Michigan. We're excited to be hosting our first live session today from our Troy office training unit. This training unit was built in collaboration with Rockwell Automation and Endress+Hauser to give live, hands-on demonstration and training utilizing Rockwell Plant PAX and E&H instrumentation with EtherNet, HART, Profibus, and standard analog output. On this training unit, we have various technologies. For level, we have ultrasonic, radar, both free space and guided. We have point level, which is the new FTL51B, which has a nice LED light for alarming situations. We have temperature transmitters from E&H. We also have, for control valves, Burkert pneumatic control valves over here, which you probably cannot see. We also have one of their electromotive control valves. We also have Abco quarter-turn pneumatic valves for on-off applications. In regards to flow instrumentation, we have the Burkert acoustic flow meter. We also have EtherNet Coriolis meters from Endress+Hauser, standard mag meters from Endress+Hauser with HART output. Again, Coriolis meter with HART output, Coriolis with HART, magnetic flow meter with Ethernet capabilities, and again, Coriolis with HART. So the training unit was built with our customers in mind. We have pre-configured training courses, which you can find under the training tab in our website, or we can develop customized training for your specific needs. The training includes, but not limited to, Coriolis meter setup, such as density and viscosity, as well as free space radar setup, including tank mapping and envelope curves. We also can provide other training for other products, such as Draeger gas detection or Parker tube bed classes. The training unit is open to all. If you'd like a more detailed dive into the Plant PAX architecture, please contact your local Rockwell salesman, and they will schedule time to visit a test drive. Before I hand the mic over, we have a few housekeeping items to cover about the presentation. We would love to hear from you, so please utilize the chat room as we will be monitoring it to answer your questions.
Hello, everyone. My name is Mauricio Figueroa with Rockwell Automation. I'm a solution consultant based out of Grand Rapids, Michigan, and my role is to work with customers to understand how to use state-of-the-art technology around industrial automation control systems to improve operations. Today, I'll be talking a little bit more about what Mike had mentioned. The training unit has a lot of smart sensors and control elements that ultimately have to be sensed by a control system and turned from smart data to contextualized information to be able to get the right information at the right time to the correct personnel. Part of that solution for the process industries is what we call our modern DCS from Rockwell Automation called Plant PAX. And Plant PAX is a scalable solution that does what I had just mentioned, bringing in the entire information and contextualizing it and providing what is necessary, such as a historian to be able to historize the data, dashboard capability to be able to produce ad hoc dashboards, as well as providing maybe a batching solution for specific applications. Again, this solution, we'll dig a little bit deeper into this during this webinar, but the one thing that I am standing in front of the control panel that has the hardware that is sensing and controlling that specific training unit. A lot of the instruments that Mike mentioned are either hardwired 4 to 20 milliamp signals, they might be HART enabled, some of them are over Ethernet IP, some of them are Profibus PA, and the idea is towards the bottom of the panel, we have signals being physically wired in, that ultimately make it to our ControlLogix I/O platform. This has redundant power supplies directly fed to it for high availability. It also connects over to our redundant ControlLogix platform. This is a platform that provides high availability, and all of it depends on a strong Ethernet IP backbone. We see a Stratix smart switch here that provides that smart integration between all of the components that are Ethernet IP enabled. We also have Ethernet IP variable frequency drive, or our PowerFlex 525 drives, that we'll be looking a little bit more into from the operator visualization platform, what kind of rich diagnostics you can get directly by adding some of these products like the PowerFlex 525 drives, the instrumentation like our flow meters, some of the temperature transducers, level transmitters, all those sorts of things. The other thing that you can't see right now is there is a local panel view directly on this control panel where you can see the exact same screens just visually in front of the panel. The one thing that I'll note is Rockwell Automation and Endress+Hauser have a strategic partnership where we have a co-development space in Switzerland, or an office, where we develop products together so that our customers can have a coherent and an easy integration whenever they're doing the integration and installing the systems. Not only do we develop products together for the sensing and the control, we also test the systems together in Ohio at a Rockwell facility where we do something called characterization, where we figure out exactly how much loading a lot of the instruments are having on our control system. A couple other things that I will bring up is we're going to be showing a set of operator displays along with some of the instrumentation, so you can see hand in hand what the instrument looks like and what kind of information you're getting from the Ethernet IP-enabled device in the operator stations. All of this is built around the Plant PAX solution that follows standards such as ISA 101 for high-performance graphics. We have also the solution built around standards around cybersecurity, alarm management, ISA 18.2. So a lot of what you'll be seeing today is really built around industry standards as well. With that in mind, we're going to spend the next 10, 15 minutes hearing from John Davis, our global process technical consultant, that's going to be navigating the design environment to do a couple things. Show the rich information that you get out of Ethernet IP-enabled devices in an operator's console through the use of faceplates. He's also going to walk you step by step on how to add a new Ethernet IP and show firsthand how easy and quick it is to add an Ethernet IP instrument into our control system, and show you the process of what that looks like.
They say a picture is worth 1,000 words, so I'm going to provide a demo of the system. As we say, seeing the instrument training unit is worth 1,000 pictures. This demonstration will provide a glimpse into the power of preferred integration between Endress+Hauser instruments and the Rockwell Automation Plant PAX distributed control system. Whether you are a process control engineer or plant operator, regardless of your responsibility, my goal is to help you recognize the value to your bottom line through reducing system integration time, increasing operational performance, and improving your maintenance processes. I will start with the Endress+Hauser Micropilot FMR51 level transmitter, designated as LIT202, that is placed on tank 200 in our system. This device is a 4 to 20 milliamp analog level transmitter, and like the majority of E&H's line of analog transmitter, this device provides HART device and diagnostics data. The HART protocol has been around since the mid-'80s and provides digital data that is imposed on top of the 4 to 20 milliamp current loop. Through the preferred integration mentioned earlier, and without any added programming, the operation and maintenance personnel are provided with additional process variable and diagnostics that can be used in the process control system. So I'm going to open up the process faceplate. The primary variable you'll notice is configured for level and confirms the actual reading coming in through the 4 to 20 milliamp current loop. In this device, the other three variables are provided to aid maintenance in determining the health and calibration of the device. Next, I will turn on some of our pumps and open up the FIT4 process faceplate that drills into the Endress+Hauser ProMass F200 Coriolis mass flow meter. Notice the four HART variables configured here: flow, a totalized flow value, density, and the temperature of the liquid. As I step through some of the engineering faceplates for this device, I want you to notice the device scaling, and the units are actually provided to the control system via HART And please take note of the range of this device, 0 to 130 pounds per minute, as that number is going to come into play later on in this particular piece of the demo. So what I want you to consider applications that if you're a control engineer, you could automatically adjust the engineering units on the process control PID loop when a process device is either replaced or a calibration range is changed in the field. So as I display the diagnostics tab here, one of the things I'm going to show you is I'm going to increase the speed of the pump. And I apologize in advance for the added noise in the background. But after a few seconds here, through the benefit of heart, what you see is the diagnostic information that was provided as the process flow exceeded that range that we talked about earlier when the device was configured from 0 to 130. Again, both the values and the descriptions that are device specific for this particular ENH device are shown. I'm going to go drop the speed down again. And as I do that, and I move it out of the way, what you should see is, and we just saw this live, we actually see the device clear itself as the range comes back down to a normal operating range of the particular device. Now I'm going to move from heart devices to EtherNet IP devices as I open up our faceplate for pump number 1, which is a PowerFlex 525 drive connected directly to the control system via EtherNet IP. On this process faceplate, you'll notice that the output current and the output power values are provided via Ethernet, again with no additional programming. Those values could be historized to capture energy usage based on this particular phase in the process, or to compare energy uses for a particular SKU made in production. As I open up the Diagnostics tab, Operations and Maintenance are presented with a list of reasons that the device is not ready to run, as well as the last fault code and the words that correspond to that fault. In this case, obviously, the device is running, so none of those particular faults are active. But you do notice down on the bottom, you get the fault code 72, which means there was a network loss, and that's presented in human readable words. So if you have experience in integrating standard Ethernet devices into a controller, you know this typically requires a lot of pre-work to understand all the device parameters and the associated address arrays. This can further complicate your design process and demand extra time to complete. The engineer would start by using the device user manual to determine the appropriate input and output sizes and adding the device within the logic programming environment, typically through an Ethernet generic profile. With the generic profile, the engineer would need to figure out the I/O size and data format, as well as determine where those device parameters are mapped into the generic array. To compare, I'm going to demonstrate the steps to add an Endress+Hauser Liquiline CM442 analytical device into the logic processor, thanks to the preferred integration between ENH and Rockwell Automation. Preferred integration is based on the Rockwell Automation library of process objects, a predefined logic library of controller code, display elements, and faceplates that let you quickly assemble applications with proven strategies, rich functionality, and known performance. Add-on profiles specifically created for the Endress+Hauser instruments is just one way that you can see our joint commitment to solutions for our customers. To save time, I already have Studio 5000 development environment open, and I will add the Liquiline through the add-on profile. So I select the appropriate add-on profile to match our device. And when it pops up, I need to give it a name. Then I need to put in the appropriate IP address for the device that's already configured in the field. And then you'll notice down in the corner when I add this, so this pops up and it actually is asking me whether or not I want to inhibit the module when it first comes online. If this was a device that had output control, I would do that. But because this is just an input and it's an analytical device, I don't have to worry about that. I'll go ahead and say yes and just let it add it. But what I was going to point out was the little yellow exclamation point that did go away then after we had it up and running. And as I reopen the add-on profile, you'll notice things like, first of all, when I actually created it, I did not need to know the I/O connection size or the data types because all that work has been done for me, and I didn't need to use a generic Ethernet profile. I used the specific one for this device. So I'm going to step through some of the tabs. I'll start with the Internet Protocol tab. And what you'll notice on here is from the physical device, it picked up the subnet mask and the gateway address. As I step into the Device Info tab, you'll see that it shows a lot of the details around the configuration, the serial numbers of the devices, and the corresponding memo sets, analytical probes that are plugged into this specific Liqualine analytical device. Next, as I step down to the current outputs, I see the device is configured to provide both pH and temperature. And as I look at that tab, both of those values are showing up with a status good or okay. So you know that it's actually reading the probe and it's giving us live values back from it. I can also click down on the Sensor tab and I can see further information about the specific sensor that's plugged in, like important maintenance information around things like the initial operation date, when the place was actually probed into service, or when the probe was actually placed into service. So the total operating time, things like that. Okay, at this point, we've added our device into our Ethernet I/O tree. So our next step is actually to add some programming, but instead of creating custom programming, I'm going to use one of the provided instruction types that are available for the Endress+Hauser instruments in the Plant PAX library of process objects by importing a pre-built process strategy. So I come up here and I import a routine, and I go grab this particular routine. And here I need to only fix a few names through the search and replace to tell the instruction the names of the I/O configuration files created when we added the instrument via the AOP. And I also prefer to name it something that matches my PNID naming conventions. So here I'll do a find and replace. I will replace all occurrences. And then I'm going to manually just go in here and fix a few of the naming descriptions just because it'll be simpler for me. So this is actually in the routine name. When I come into the tags, one of the things that I'll point out is, so it did pick up the name that we gave it when we added it to the Ethernet I/O tree. So it's going to use that existing name. It's going to create a new instance called AIT 101 device, and there I'm going to also add the description at the beginning so that it knows it's for tank 100. And then it's going to create an Ethernet IP diagnostic table specific for the Liqualine, and then it's going to actually keep using an existing Ethernet IP units table that already exists in the processor because we already have Ethernet IP enabled flow meters that are using this specific data table. So I'm going to say OK at this point. And what this is asking us is when we import this particular routine, do we want to take the safest options and keep our import logic edits set as pending, so they won't actually be scanned and active. That's the safest, and that's what I'm going to do, because you'll notice up here that I am running the system live. You may not be able to hear it very well, but I actually have pumps still running in the background. The other choices for these would either take it into where it would actually accept the edits already, or even in one case finalize everything and it would just immediately be scanned. But this is the safest choice. We'll go ahead and select OK. And then what you'll notice is it'll import in the routine. No errors, which is always good. We look up here, and here's the routine that we have. So it brought in the instruction. You notice that the reference input is matching that input image from the AOP that was created a little while ago. There's our engineering units, and there's our specific ENH EtherNet IP diagnostic table for the Liquid. You will also notice that the values are all 0 and nothing is changing, because this particular routine is currently not being scanned. You notice again all the zeros that are here. And what we have to do is we have to go up to our main routine. If I scroll up here, what we're going to do is we're going to duplicate our jump to subroutine. So now I've got one in there, but it's also got edits pending. So if I come up to here, I'm going to go ahead and finalize all edits in the program. So it'll take these couple changes to this routine into the AIT 101. And as I jump over to this, we actually should see the values updating. So before, where they were zeros, now we're seeing the 8.26 and the 72.95 values for temperature. So those values are reading, and at this point, our programming is actually complete, and we're ready to move on to the operator interface portion of the plant PAX. So now I'm going to jump over to View Studio, and similar to Studio 5000, I have it already open, and I have it already up on the screen that I want to make modifications to just to save some time. So now what I'm going to do is I'm going to actually add my process library object to my plant PAX system screen. So I'm going to open up my global object screen, copy the global object, go back over to my overview screen. I'm going to go ahead and paste the object in, put it in the appropriate spot, and then I have to update the global object parameter values, and the only two that are really required. So the first one, if I hit refresh all folders here and make sure that I pick up my device that we just added. And then here, I also need to put in the path. And then there are a couple options here that I like to configure. The first is this display option that it pops up the process operator faceplate to the bottom right of the object that actually calls it. So this is a / relative position option. And then I also like to add this so that based on the user level of security that's logged into the operator workstation, it'll determine whether or not the operator gets a quick faceplate, or if it's a maintenance or engineering person and he gets a larger faceplate that has more diagnostic information available. Either person could kind of get to the other ones, but it's just something that makes it a little bit less clicks for an operator sometimes to get just the stuff that he cares about. So once that's on there, I have to save it. So now that I've saved it, we'll jump over to the runtime environment, and you initially notice that the object doesn't exist because we have to refresh our display. And then now it's on the screen. As I open it up, open the new object, you see the process library faceplate that corresponds to the ENH Liquid line. Immediately get that both the pH value and the temperature are available. You have a diagnostic tab that is going to work very similar to the other diagnostic tabs that we saw both in hard and the other Ethernet devices, and that because there was a custom pre-made Liquiline diagnostics file, you'll actually get text and the human readable words that go along with it. And that's all, again, all that's just part of the preferred integration between Endress+Hauser and Rockwell Automation. And all that allowed us to integrate this instrument into our control system in really just a few minutes, saving engineering over completing the same task with the standard instruments. One thing to consider is if you have more than one instrument to add and commission, you could actually multiply that savings by copying and pasting kind of through the same steps, but actually doing a little bit quicker using the magic of copy and paste, and be able to quickly duplicate some of those objects both in all those different environments, both in the I/O tree, inside of our logic routines, and then even up here in the operator interface. So you consider that value that you're provided by having all that additional instrument data available for operations and the diagnostics data available for maintenance on the screen of your plant terminal. So next we're going to actually jump over and talk a little bit about another Ethernet device. We have the E&H ProMass F100. I will zoom in on this process faceplate. You'll notice that on this we have the main process variable. We also have 3 different totalizers that are coming in that are configurable through either the add-on profile or the device web page. And along with those particular totalizers, we have a details pane that I can slide over the top of this. And then you can see, besides the 3 totalizers, I also have mass flow, a volume flow, a corrected volume flow, a density, corrected density, and temperature. I have the option of selecting different process device parameters in the particular one, and these are the ones that we've chosen to select for this particular device. Also, with the appropriate security level, which I have, I can actually go in and I can clear the totalizer values if I choose to. So along with all these process variables that are available, you also get a diagnostics tab that is very similar to what we got on the other Ethernet IP devices and the HART devices, where you would get a number, a fault number, and then you also get the human readable words that would correspond to that, because that particular device has a specific diagnostics file for that exact device. The technology, experience, and preferred integration expertise created by the alliance of Endress+Hauser and Rockwell Automation delivers highly efficient solutions for today's process automation and instrumentation challenges while working towards tomorrow's breakthrough. Thank you.
Thanks again, everybody, for joining us for the webinar introducing Ethernet IP integration between E&H instrumentation and Rockwell Plant PAX. If you'd like any further information on our training courses or customized courses, please give Forberg's salesman a call or your local Rockwell salesman. Thanks again, and have a great day.